Section 9.3, Volumes of Pyramids and Cones. What you'll learn? To find the volumes of pyramids and cones. Why learn this? Well, one thing to consider is that you would consider volume when you fill an ice cream cone or use a funnel. The contents you need to fill a prism with base area capital B will fill exactly 3 pyramids with the same base area and height as the prism. And a check of the skills you'll need. Number 1, vocabulary review. How are the shapes of pyramids and cones different? And number 2, what shape is the base of each of the figures below? A key concept, the volume of a pyramid. The volume, V, of a pyramid is 1/3 the product of the base area, capital B, and the height, H. Example problem 1, finding the volume of a square pyramid. Find the volume of the pyramid below to the nearest cubic centimeter. Well, to begin, we'll consider the formula for the volume of a pyramid. 1/3 base area times height. And now we'll consider what we know. It looks as though we know the base of this pyramid is a square with side length 10, so our base area, denoted capital B, will be 100 square centimeters. But note, we're not explicitly given the height of the pyramid. Notice the 13 centimeters doesn't represent the height, but it measures the distance from the vertex of the pyramid, the point at the very top, down to what looks to be the midpoint of one of the edges. Notice shaded in blue, though, is a right triangle. That'll be useful for us. So consider that right triangle. And here we have 13 centimeters. In our new right triangle, that would be considered the hypotenuse. H, the height, would be one of the legs of our right triangle. And then the other leg, well, we know that the full length across the base is 10 centimeters, and it looks like our right triangle would be exactly half of that. So 5 centimeters. Now we use the Pythagorean theorem to solve for h. So recall, in a right triangle, the lengths of each leg squared added together equals the hypotenuse length squared. So to make sense of that in this example, we will have 5 squared plus our other leg length squared. Our other leg is h, that's our unknown value, and that will equal our hypotenuse length squared. So to simplify some of this, 5 squared we know is 25. Subtracting 25 from both sides of the equation, and applying the square root, right? To undo that h squared, we would apply a square root to both sides of the equation. The squared and square root cancel, and we just find that h equals the square root of 144, so 12. All right, so now we know our height h. We can add that up above along with our capital B, our base area. So h equals 12 centimeters. And now, plugging both of these things into our volume formula, we will find that volume of our pyramid equals 1/3 times 100 square centimeters times 12 centimeters. Recall that multiplication is commutative, meaning we can multiply these 3 things in any order we like. 1/3 of 100, well, 33.333. I think right away 1/3 of 12, that's much simpler. 1/3 of 12, of course, is 4. So that multiplying in this order, 1/3 times 12, we would have 4 centimeters times 100 square centimeters. And that, of course, equals centimeters cubed, 400 centimeters cubed, the volume of our pyramid. Very good. And a quick check. Number 1, find the volume of the pyramid at the left to the nearest cubic meter.